Hello, I'm Tim Lindquist. I'm a professor in the software engineering program at Arizona State University. And this is a video that supports our course in native mobile app development, SER423. And in this video, we're going to develop our first single view iOS app using Xcode. So let's go ahead and get started. You can see this is the web page for the class, and under the schedule this is actually still part of Unit 1, and it's the last thing in the iOS section of it that looks at developing your first Xcode and iOS app. So let's go ahead and spend the time just looking at IDE, the IDE for Xcode and developing the app. Before this video, you should have gone through the video and actually looked at the tour of Xcode's UI because we'll be using the IDE Xcode for doing that development. So in this case, I want to talk more about the app itself and what goes into a project and building and so forth. So we're not going to get started with a playground, we're going to get started with an Xcode project, an iOS project, a single view project. We're going to call this delete me because we're just going to do a simple project, a single view app that has one button and one text area that we manipulate. So no team, Tim Lindquist, and language is Swift. We're not going to use core data. And this is where I want it placed. It's going to be the default for this semester. And we end up with a blank project. And as we looked at in the last video, actually you can or execute it. So, oops, I did it on a 7+. I want to switch that to a 7, but that's okay. So what's happening now? Well, we have various resources that are part of the project, and as I have mentioned before, when you create a new project, Xcode will provide a template that includes the framework for everything that makes up an app. And when you run that app, different from Android, when you run that app, a compiler compiles the code. In this case, there are two source code files or classes. Both of them are classes. We'll look at the contents actually next week in the next unit. One of them is the app delegate, and the other one is the view controller. So the view controller, as I said, this is a single view application. So here's my view. All right, so I have one view. Right now the view is empty. We're going to put some stuff into it. I have one view, and the controller for that view is this viewController.swift. And the view controller class extends the UI view controller. So this is the base class for view controllers in iOS. We'll see other kinds of view controllers for different kinds of navigation and so forth. But again, what is a controller? Well, a controller is the median or the mediary between what the user sees and then the underlying data. So for example, if I have a button in my view, there will be a button object in the view, and when the user selects that button, what happens is that the view controller, a method within the view controller, will be called, and I write the code in that class that implements whatever action I want to have occur in my app when a button gets pushed, or when that particular button gets pushed, right? So the view controller is the actions that will cause things to change on the view, will provide data for the view, and will handle any kind of an event that occurs as a result of the user using the app, or in this particular case, using a single view or screen within the app. All right, so these source code files, in order to run my app, these source code files have to be compiled. Meaning that with Swift they get compiled into object code, and that object code is executable. However, one of the main reasons that Xcode is not, in my view, one of the main reasons that Xcode is not implemented on multiple platforms, aside from Apple Mac OS, is because the compiler, for the case of mobile devices, is what's called a cross-compiler, meaning that when it compiles these Swift programs to put them into, we're going to call it an app bundle, which is in Android it's a .apk file. It's an archive that contains everything that we need in order to execute the app. That bundle has to get moved onto the device itself. In our case, the device is this simulator. All right, it has to get moved onto the device, which is a separate processor, and then it gets executed on that device. All right, so these Swift classes get compiled into object code, but that object code won't run on the machine that I'm doing the development on. All right, I'm doing a development, in my case it's on an x86, a 64-bit Intel machine, Intel processor, but my iPhone and or the simulator is an ARM processor, and the instruction set for the ARM is totally different than the instruction set for, or is different enough than the instruction set for the x86 that in fact the compiler can't generate code that will run on both devices. All right, so it's called a cross-compiler, and it is compiling from the development environment of an x86 Mac OS device and targeting an ARM processor running iOS. And that's why we need to have a simulator, right? If it would target code to run on a laptop, on an x86, then I wouldn't need a simulator in order to execute it. Okay, so the code gets placed into the bundle. What else gets placed in the bundle? Well, we have this storyboard, and the storyboard contains for us all of the details of the view. And before we go any further and talk about how it goes into the bundle, let's just play around a little bit and put something in our view. So over here in the utilities area, we have the ability in the bottom part of it. Notice for all of these areas we can change their size. All right, we have a palette. When we select the object library, we have a palette of all the things that we can put into a view. All right, so there's a navigation controller, a tab view controller, a collection view controller, a tab bar, right? And the icons kind of try and show. So a tab bar on iOS is typically an area at the bottom of the screen that has different tabs, icons for tabs that provide you with different manifestations of that particular view. Split view controller and so forth, right? So those are the different controllers. And then when we get down toward the bottom, here are the individual components that we can place on. So here's a button, and in order to put a button into our view, we simply click on the button and drag it and place it where we want it placed in our view. So we're going to have a single button in our view, and that button, let's get this guy up a little bit bigger. And my plus and minuses here. So I have a button, and notice that when I have the button selected, what appears in the top half of the utilities panel are the properties for that button. Down. So the properties, so again, this is a tabbed panel. The top here is a tab panel, and here are the tabs. This is the property tab, or the attributes. Attributes are properties for, in this case, a button. So one of them is the text that's contained in it, and we're going to change that text to click me. All right, so now when I run the app, there'll be a button in the middle of the screen, and it'll say click me. There's other properties that we can change if we want to. We can control how it's positioned horizontally and vertically. We can scale and do background for it, change its shape, and so forth. Add an image to it, and all kinds of different options that are available. We can do that with all dragging and drawing. But for our simple app, we're going to have two things. One of them is a text box, and the other one is a button, right? So when the button gets clicked, we're going to put some stuff in the text box. Okay, so now I'm going back. This is all part of explaining what goes into the bundle. As part of the bundle, realize that each of these things are objects, right? We can create them under program control if we want to. So there is a button class, and when a user is actually looking at the Click Me button, there has been a constructor that's been called to create a button object, and that button object has been added to a view. All right, so if I go back here and take a look at my view, this is actually a stack. There's a Click Me button, and then there's a round-styled text field that have been added to my view. And as I go down list, if I have controls that I've added to my view that may take up even the whole view, I can add them on top. So the view really is a layered thing, and the top of the view actually is visible over the thing that's underneath it. And the view goes, as you go down the screen, you go up in terms of the stack of the view. But in any event, so I've got these two things that are now on the view, and there are objects at runtime that represent them. Well, in those objects, there's no source code that you manipulate in order to create or control those objects. That doesn't mean that you can't call a constructor for a button at runtime, right? So suppose at runtime I wanted to add in a new button to this app and to this view. I could actually call the button constructor, create a button object, and cause it to be added to my view, and it would appear on my view. But the easiest way in order to create a view is to do it with the storyboard. It gets represented as an XML file. That XML file goes into the bundle. So when an app starts execution in an iPhone, what happens is it reads in all the stuff within the bundle, part of it's executable code, but some of the first code that gets executed is to deserialize that. It's called deserializing that XML file that represents the launch view. All right, the launch view is the one that the arrow points to, and that causes the view objects to be created from a serialized form, from an XML form, and conceptually from an XML form, and then populated to show our view. Okay, so that's all part of the bundle. There may be other things that we store as well. Assets. Those assets may be icons that we use as a part of it. A launch icon, an app icon. Maybe we have a splash view when the app launches, and we want special icons for that. Or we use icons or images in other views. All of those things actually have to be part of our bundle as well. And then there's this info.plist. Turns out with an iOS app, there may be many property lists, but in particular, info.plist contains all of the system type things and any permissions that our app requires in order to get it to run. So all of those things get bundled together to create the executable app. Okay, so let's just finish up with this simple example. I've got a storyboard that has all the components in it that I want. When I use the concentric circles over here for the assistant editor, what it will do is to provide for me a view in which I get not only the storyboard of my view, but also I get the view controller. And what I'm going to do is make two different connections. These are called IB, Interface Builder. The storyboarding tool is an interface builder. And if I select an icon there and then depress and hold down the Control key and then use the mouse to select and drag, what I can do is to create in my code a hookup between that component in the view and my controller. All right, so now what I've done is to hold the Control key and then with the mouse select and drag that control into the class. And now I'm going to release both of the keys. and it shows me a dialog. It says I'm going to create an outlet in my view controller object. The name of it is going to be my text field, my TF, right? So it's going to be an outlet, and its type is a text field, UI text field. Storage class we'll talk about later on. Suffice it to say there's no garbage collector in iOS. Consequently, special things have to be done in order to make sure that apps don't leak storage. All right, so notice after I confirmed that, I now have an IB outlet whose storage property is weak. It's a variable, my TF, a UI text field, and notice that in fact it's an optional value. All right, so that's one of the wire-ups I have to do. I also now have an icon showing up in the code that shows the relationship into the storyboard. So this is going to be the outlet. In other words, I'm going to add the text. I can either get text from my TF or add text to my TF. Now I need to have a method that gets called when the button gets clicked. And in order to do that, I select the button, hold and depress and hold the control key, and then use the mouse to drag that button again into my source code, into a place where I can create a new method. And that asks again to insert an outlet. And in this particular case, the outlet it's going to be an action instead of an outlet. Its name is click me got clicked. Very simple one. And it is a touch up on the inside, and it's going to have an argument called sender. So I hit connect, and now click me got clicked. So the only code that I'm going to do inside of this, so now every time when the app runs and click me gets clicked, what I'm going to do is my TF dot text equals ouch. All right, so I'm going to add the message ouch into the text field. So with that, we can actually go ahead and execute this thing, and it should work. If it doesn't, who knows why, right? So it's built the bundle, and it's sent the bundle to the simulator. And it's just now being installed in the simulator. And there it is. And for some reason or other, it didn't like that. There we go. Got installed. And now when I do click me, I get ouch. I must have had select to do one of the tests, one of the predefined tests. But you can see when I click the button, I get the ouch message shown in there. So there's an example of the simplest app, the connection between the controller and the controller being the source code. In this case, it is the viewcontroller.swift file, and also the storyboard or the view itself. So let's leave it at that for this session. Actually, there's enough material now in the iOS side for you to do the first exercise that's defined within both the web page. So this guy, the iOS part of a single view iOS app, and in this exercise, you're asked to create a single view application that will display the information about a place, a thing called a place description. So here are all the different components of information about places. And we're going to actually expand upon this example as we go through the rest of the course. Okay, that's the end of this video.